Hey guys, so today we're going to do a demonstration to show Le Chatelier's principle in action. So, safety as always. Got the hair pulled back, we're going to put on our goggles. And we are going to need the hot plate, so I'm going to go ahead and turn it on to get it heated. Okay, so our first step tells us to add cobalt 2 chloride. So this is cobalt 2 chloride. And we're going to add 20 drops to 2 different test tubes. All right. So there's test tube 1, test tube 2. Okay. So we have our cobalt 2 chloride in both test tubes. Now it asks us to add 1 ml of water to each, which I have already pre-measured out for us. Now, when we add this water to our cobalt 2 chloride, we are going to form this complex ion right here. And a complex ion basically is a polyatomic ion. It has a metal in the center, and then surrounding it is something else. In this case, it would be 6 waters, okay? So, here's my water. Now, what color do you see? It's still a red color, correct? So this is red. And I hope that red, you can see, I wrote red. I hope that shows up. Okay. Now, our next step is going to be, we need to add hydrochloric acid. And now this is very concentrated hydrochloric acid. Okay, so we're going to add, and this is hydrochloric acid. And so, let's see what happens when we add hydrochloric acid. As I'm adding the hydrochloric acid, do you notice a color change starting to happen? All right, so watch when I add this hydrochloric acid, watch what happens. So you can see a color starting to happen, and then it goes back to the red. There we go. Now, here we go. So now what color is this? Let me put a piece of white paper behind it. So this color is now blue. All right, so when we added the hydrochloric acid, it turned blue. Why did it turn blue? We added hydrochloric acid. So here is our chloride ions that we are adding. All right, and we have formed in the process this polyatomic ion, COCl4 2 minus. So, Le Chatelier's principle, when I add something, I'm going to shift in the opposite direction to use it up. So I added chloride ions, and what did I see? A shift to the right in order to use that chloride up. The goal is to go back to where we started, right? Where did I start? I want to go back to where I started. So if I have too much chloride ion, I have to get rid of it. All right, so now it says for us to do water. We want to put water back and see what happens. So here we go. Let's add water. And now this is distilled water. Okay, so here's my distilled water. Do a little swirl. And what color have we done? We are now back to red. Why am I back to red? I added a product. When I add something, I shift in the opposite direction in order to use up what I added. So because I added water, it's going to be used up. Again, let's get back to where we were originally, all right, or as close to it as possible. So I added water and I shifted. Okay, so let's look at the next one. It now tells us to take this tube and place it into a water bath. So we're going to just kind of let that one sit for a second and let it do its thing. And let's move on to the final one. All right. So I now have a test tube here. All right. This was just the regular cobalt 2 chloride, which I have not added anything else to except for the water to form that complex ion. We are going to add silver nitrate and see what happens. Okay, so what have we got going on here? All right, we added some silver nitrate to this, and we do start to see, y'all can see, we have a precipitate forming. All right, that white stuff that's kind of floating around in there. All right, so what's happening? The silver is combining with the chloride to form this silver chloride, which you can now see in there. And we are finished here. So let's take a look at what we have. Okay, so I have my hot hands. And what color did this one turn? It went from red back to blue. All right, so we saw a shift back to the right. Now, is this reaction endothermic or exothermic? We have two options. If it's endothermic, heat is a reactant. if it is exothermic, heat is a product. So what did we see? We saw when I added heat, a shift back to the product side. So I added something. So here we need to figure this out. If I add heat and it is exothermic, a product, I would shift to the red side. If I add heat and it is endothermic, a reactant, I have to get rid of the reactant I added, so I'm going to shift to the blue side. So because it turned blue, that tells us this is an endothermic process, and we know that because we added heat, which is a reactant, and we saw a shift towards the product side. Now with this test tube that we were working on, if we can just come back to this real quick, if I was to continue to add silver chloride, or I'm sorry, silver nitrate, what do you expect to happen? Chloride is being used up here to form silver chloride. So I am taking it away. So would we ever see a shift to the blue side? If I take away chloride ion, I have to replace that chloride ion. So it is shifting back to the red side. So that's why we did not see a color change here in this test tube, because we are removing that chloride, so the equilibrium is going to come back to this reactant side in order to make what is being used up. So here's a good demonstration to help demonstrate Le Chatelier's principle. I hope that you have found this to be helpful to you in your understanding of this concept.